Okay, this is a video version of the notes from Friday, September 29th, because there were so many people out of class. So for this first problem, the focus of these 4 problems is being able to take the derivative, because what's going on is more than just one rule. So we've already focused a lot on simplifying, so what we're focusing on today is, can you take the derivative of all the parts that are there? So let's look at this first problem. We need to identify the rules. The rules that we're going to use to take the derivative of this function. We're going to use the chain rule because we have an outer function of 9 and we have all of this on the inside. So we're using the chain rule. So we're going to identify an outer and an inner function. And then when we look at the inside, we have 2 functions. They're not plugged into each other, but they are multiplied. So we are going to end up using the product rule. So first, we do the chain rule first because the 9, that exponent, is on the outside, and with derivatives, we always start our way outside and work our way in. So our outer function here is just the 9th power. Our inner function is everything that's on the inside. So we have x, and we're going to rewrite that exponent. So what's on the inside goes on the top. What's on the outside goes on the bottom. So that's x to the 2/3 times 7x minus 1 to the 5th power. Okay, so now we'll actually take the derivative of this now that we've found all the parts. The first thing we do, again, the outermost thing is the power, so we're going to have to use the chain rule. So for the chain rule, we do d outer. So 9, we leave what is inside of the parentheses alone. So it's that whole thing. Oh, that's a 2. X to the 2/3 times 7x minus 1 to the 5th, all to the, so we subtract 1, and that's 8. The 8th power. So here's d outer. Now we're going to do d inner. Dinner. There's a little mark. Okay. So when we do that, we want to make sure that we multiply everything. So I use a bracket when it gets big. You can use a parentheses or just times. It's all the same stuff. So our product rule is the first. So we literally write the first. So our 2 functions are over here. So the first, so x to the 2/3 times the derivative of the second. So the second is here. And when we take the derivative, we have to use the chain rule again. So we're going to have times 5. We bring the 5 down. Leave what's inside the parentheses alone. Subtract 1 from the exponent. So that was our d outer, and d inner, make sure that you multiply by 7. So we have first d second plus, so we have to have a plus here, we're not quite done. Second d first is the rest of our product rule. Okay, so second, we write down the second one, 7x minus 1 to the 5th. We literally write what we see. Now we take the derivative of the first, 2/3 x, and then we subtract 1, so we get a negative 1/3. So we have our product rule. We did d outer, d inner. Everything, we can use our original equation as a checklist. We took the derivative of this, we took the derivative of the 9 on the outside, and we took the derivative of that. That's how we know we're done with our derivative. I know that it's long, but you need to make sure that you have all of your parts together. Again, we're not focusing on simplifying, we're merely focusing on, can you get all of your parts of the derivative and know when to stop? Okay, so the next problem, we have f of x equals the cotangent squared of 9x plus 1. Now before we get further, I want to rewrite this. This squared right here is the same thing as writing cotangent of 9x plus 1 all squared, the whole thing. So again, we recognize chain rule because we have an inner function happening. And what is actually happening is we have the 9x squared plugged into the cotangent, which is plugged into the squared. So we actually have a chain rule that has 3 layers here. So you can think of a peanut M&M. A peanut M&M is covered in candy and then chocolate and the peanuts all the way in the middle. So that's what we're thinking about, these layers that are happening. So the outer, let's see if we can identify all the way on the outside is that squared that is happening. Then, because we always work our way out to in, so all the way on the outside is outer. The next inner part would be the cotangent of something. And then our last part, so think about the peanut all the way in the middle of that M&M, so maybe you can call it inner squared, inner times 2, the the innerest, whatever you want to call it, is going to be the 9x plus 1. So when we apply our chain rule, we take the derivative of one thing at a time. So we could have 5 things that we need to take the derivative. Usually AP Calculus is going to stop here, and they're not going to do more than 3 layers. That's generally where they stop. So we don't really have to worry about it having too much going on. So let's take our derivative now. One thing at a time. We start with the outer. The outer is the squared. So we bring the 2 down. We write exactly what we see. Remember, we're going to leave all this inside alone while we're dealing with what's outside. That goes down to the first power. So we've done the derivative of the squared. Now the next inner is cotangent. So the derivative of cotangent, it's going to be negative. So we're going to have times negative cosecant squared of, we leave the 9x plus 1 alone still. So now we've done the derivative of that. Now, our last piece, what's nice about the chain rule is once you take the derivative of something, you get to forget about it. So we did the squared, we're done with the squared. We did the cotangent, we're done with trig for this problem. The last thing that we need to look at is 9x plus 1. So we take the derivative of that, which is just 9. And we have taken the derivative of all 3 parts of this equation. If you really wanted to simplify this, the only thing that you could do is you could multiply the 2, the negative, because technically this is a negative 1, and it's not stuck inside. It's in parentheses, but there's no exponent on those parentheses, and the 9. So we could multiply all those together and get a negative 18 cotangent of 9x plus 1, can't change, times cosecant squared of 9x plus 1, can't change. So that is the most simplified form of this. I know it's long, but there's all our parts. That's all we can do. That's it for this problem. Let's look at a couple more. Oh, don't want that. So let's continue to think about our peanut M&M analogy. So we have the shell, the candy shell on the outside, and then comes the chocolate. Then all the way on the inside is the peanut. So if we're looking at this, the outermost function, the thing that is happening on the outside the most, is the tangent. Then as we move on to the inside, so our next layer is chocolate, would be the sine of something. And the peanut is all the way on the inside, so it's x over 3. And really this is 1x over 3, so we can just move the x out to the side and say this is 1/3 times x. That's going to help us when we're taking our derivative. You don't have to do that, but it's nice for later on. Because it doesn't, just because it's fraction doesn't mean it means quotient rule. Okay, so let's take our derivative. We start from the outside and work our way in. So first is tangent. The derivative of tangent is secant squared. And what do we put on the inside? Everything that's left. So we do not change it. So we have sine of x over 3. That is our first part of the derivative. So we're good with that one. Next, the chocolate. So the sine. The derivative of sine is cosine of x over 3. We leave the x over 3. We're not done with that yet. We're done with the chocolate, though. Our next layer is the peanut in the middle. We take the derivative of 1/3 x, and all we have left is 1/3. And that's it. We did all 3 parts. We have the shell, the chocolate, and the peanut. That's all the parts of our derivative. The only thing you could do here is you could move the 1/3 up to the front if you wanted to, but other than that, it's already simplified as it is. And now the last problem. Before we get started, I want to make sure that we rewrite this. So we would have a 1/3 power due to this cubed root out here. Then, if you look on the inside, it's just 9 divided by x squared plus 1. So we don't have to use the quotient rule or the product rule for this because that 9 is just a number. So we could rewrite that 9 times x squared plus 1 doesn't have an exponent, so it's technically 1. And if we moved it on the same level as 9, it would be a -1. So now this is a little bit easier. That way we don't have to do quotient rule as well. So when we're finding our 3 parts, the shell on the outside, our next layer is chocolate, and then the peanut. Okay, so the shell, all the way on the outside, we have a 1/3 power. The next layer in, so that's encasing the peanut, is the 9 and the -1 power. So we have 9 times, we have a -1 power, which leaves us, our peanut is the x squared plus 1. So let's take the derivative of this. So all the way on the outside is the 1/3 power. So we're going to take the derivative by bringing the 1/3 down, subtracting 1 from the exponent, so we get a -2/3. And what's in the parentheses stays. We do not change it at all. It is 9 times x squared plus 1, all to the -1st power. So there's our first derivative, and we are done with that. We can move on to the next one. So the chocolate is only the 9 to the -1 with the x squared plus 1 in the middle. So again, -1 times 9 is -9. Leave the x squared plus 1 alone. Peanut doesn't come till the end. -1 minus 1, -2 power. So we've done that one. Now the peanut. So we have x squared plus 1. We take the derivative, it's 2x. Okay, so we've done that. We've checked off all of our things. We've taken the derivative of all 3. We had 3. We took the derivative of 3. We're good. We have finished this derivative. Now you can simplify, but remember, we're not focusing on simplifying right now on these 4 problems. We're focusing on, can you get the derivative of all the parts that are there? This concludes your notes for section 2.4. So 2.4 is over. We will be starting a new section on Monday.